and welcome. Today I would like to talk about dark matter and dark energy. These two forces are very important for the shaping of the universe. So let's begin. First of all, did you know that 95% of the universe is dark? Basically, it's either dark matter or dark energy. Only 5% is ordinary matter like stars and planets. Isn't it very weird? We only know about 5%. We don't know what the other 95% is. And the question is, how do these forces make the structure of the universe, and how do they make its faith? Well, let's start to understand what we know at least about dark matter. Basically, the hidden skeleton of the universe. It is a form of matter that does not emit, absorb, or reflect light, but its presence is detectable through gravity, galaxies majorly, and some other cosmic structures. And yeah, basically, dark matter is the thing that holds galaxies together, because if you see in the picture, you can see the outer areas and the inner. From what we should expect from theory of relativity and gravity, how we know it, the stars on the outer layer of the galaxy should be going way slower than the inner, but they are going in about the same speeds. So that's how we found basically dark matter. Now, how do we detect specifically dark matter? Through gravitational lensing, which is a process that you take a group of galaxies, and the light which is behind them, because if you don't know, when you have a lot of gravity in an area, it curves the fabric of of space. So the photons that start in the other in the opposite direction of you curve around the system, because a curve is created by their gravitational force, and then it comes to us distorted like we see it in this picture, but by analyzing the light we can fix it, so it's not a problem. And galaxy rotation, as I said before, stars on the outer edge should be going way slower than expected, should be going way slower than they are actually going. And yeah, now the force that drives the expansion of the universe, that's another interesting thing. Basically, dark energy is the thing that makes the universe expand, and it's a very weird thing, really, because let's say, to understand it fully, I am in the one side of the desk and you are in the other side of a desk, and let's say we are two galaxies. We are not gonna just start going backwards, but the table in between us will just get bigger. So space itself becomes bigger. I don't know if it is easy to understand. That's my greatest way to say it. It was first proposed by Einstein in his equation specifically, but he later removed it and called it his greater mistake. But in reality, the greater mistake was that he thought it was a mistake. That's how brilliant Einstein was. Now, the expansion of the universe, we found out about this in the 90s because we observed galaxies and we saw that all the galaxies except the few that are gravitationally aligned with us just are getting farther from us quicker and quicker and quicker, while some galaxies are getting closer. Only the ones which we are gravitationally aligned with, like the galaxy of Andromeda. Now, it's ironic that they have very similar names, but they are exactly opposite because dark matter pulls the galaxies together and dark energy pulls them apart. So that's a very interesting dynamic. By the way, dark energy is winning and by a lot. Um, yeah, and because of these two forces, just from these two we can predict the end of the universe. That's why they are so much a hot topic as they are. Yeah, they are called the Big Freeze, the Big Rip, or the Big Crunch. There is also another case which is getting a bounced universe. We are gonna talk about that in a bit. Below you can see a picture showing the universe that it is like how it expands. Like you see that they are closer together in the start and then expands. While in the other picture we can see dark matter, which is not stated there, which is the blue thing around the galaxy. Yeah, also dark matter is usually around galaxies anyway. You can see it because they have make it visual. Anyway, that's an interesting fact. Anyway, uh, now we want to find answers. What are these things? You saw I said some things about them, but it's really just what's an apple? An apple is something that falls from a tree. That's what I said to you, base. Uh, this is everything we know. We don't know what's composed of, what can do to us and stuff. Only that dark matter uh, inf influences gravity, interacts with gravity. Yeah, scientists are trying to find particles that can be dark matter candidates. The Euclid telescope, launched by ESA, for those who say that ESA does not do a lot of stuff, yeah, they do. And Euclid tries to map uh, to map the universe basically as much as it can, and it also observes things that will be studied for dark matter and dark energy, and in the future theories such as modified gravity MOND and string theory will propose new ways to explain these forces, which is very I am very excited, I have to say. I might not seem excited, but I am. I'm very excited about those discoveries. So yeah, this is the Euclid telescope. Now, let's go back when we were before. And what will be the fate of the universe? Because as I said, dark energy and dark matter will decide that. So, because it's not so little, we cannot be sure, but we have a few guesses, okay? So, the first one is a big freeze. What is a big freeze, you will ask? So, we know the universe is expanding, right? But the temperature within the universe remains the same. So, if you don't know, the heat or the temperature uh, basically goes from one thing to another. The universe has an amount of heat. It cannot produce more or some of it to be lost. If you have a very warm, if you have very warm water and very cold and you put them together, just the heat from the warm one will just go to the one which is colder. So it will not, the heat will not be diminished because the cold water will actually become hotter. So anyway, but if you just have more space than before, the temperature is going to be going down. And if the universe continues to expand, at a point it will reach 0 kelvins, which is when even molecules do not move, because temperature is how much a molecule moves, and 0 Kelvin is when it freezes. So you will not be able even to understand that time passes. It is that crazy. You will not be able to understand that time passes because everything will be freezed. Anyway, next up is the Big Rip, which is basically dark energy dominance forever. It is already dominating, but I mean way more dominance than now. And in the way I say that is it's going to expand. Okay, it will expand so much that we will go from galaxies going away from each other to stars going away from each other, whole galaxies being ripped apart, and then we'll get planets going away from their stars, so the solar systems will be destroyed, and then even molecules and atoms will be split apart. We don't know if that's even possible, but that's what's predicted. Yeah, projected. Sorry. Now there are also the other two cases. A big crunch. Basically, if gravity gets to be dominant again, because in the start of the universe it kinda was, not really, because the force of the explosion or whatever that was, the force of the force made the universe expand, basically dark energy, but gravity slowed the expansion. It was expanding slower and slower and slower, but then it started accelerating, which is when dark energy took over. So the big crunch is if gravity re regets dominance and crashes the universe down to the size of an atom, let's say. Yeah. And there is also another case, which is my favorite. Is the one that probably will not happen, but you know, in astronomy, sometimes it's quite, it's quite, it's quite good to romanticize, because if you like, okay, it will get ripped apart, it will freeze, something like that, but just the possibility that can be something more or less extreme, that everything ending that you ever knew will ever knew. It's it gives your soul a place to stay, basically. And yeah, it's a balanced universe where dark energy and gravity are tied, so neither one dominates, and the size of the universe remains stable. A universe of unknowns, a frontier of physics. It is, as I said, dark matter, dark energy. They are two very complicated subjects um, that will that will probably revolutionize our understanding of the universe. And I would like to make a conclusion that the quest of answers does not end with current theory, so we don't know everything. but it extends to the minds of the next generation of scientists, dreamers, and explorers. We are living in an age where the universe invites us to question everything we knew, we thought we knew, and it will be our collective curiosity as humanity and ambition that will light the way forward for us. I hoped I hope this video makes you motivated in astronomy, and yeah, so that was it, and goodbye.